Hi everyone, I am Akshay BC from Sri Venkateshwar College of Engineering, studying in Cybersecurity 5th SEM. My topic is extending the transition function to strings. This representation explores the evolution of transition functions from single characters to strings. We'll delve into the motivations, definitions, advantages, and real world implications of this expansion. Introduction to finite state machines. Finite state machines are mathematical models of computation that represent a system with a finite number of states. They transition between these states based on input events. Transition functions. The heart of an finite state machines is the transition function which determines the text state based on the current state and the input symbol. Formal definition of a transition function. Definition: the traditional transition function delta maps the states and into symbol to a next state. Example: if you are in state q1 and receive into a, the function returns the next state q2. Domain and range. The domain of the function is the set of all possible state and input symbol pairs, and the range is the set of all possible states. Deterministic. For each input symbol, there is only one possible next state for a given state, making the transition function deterministic. Limitations of traditional transition functions. Limited input. Traditional transition function only accept single characters as input, which can limit the complexity of patterns they can recognize. State explosion. Handling sequences of characters requires creating separate states for each possible combinations, leading to state explosion. Lack of flexibility. They they lack the ability to handle complex patterns or sequences of characters effectively, limiting their applicability in some cases. String matching. They struggle to efficiently perform string matching ta- tasks which are crucial in many applications. Motivations for string based transitions. Pattern recognitions. They need to identify complex patterns which within strings led to the development of string based transitions. Data processing. String based transitions enable finite state machines to process textual data and identify meaningful sequences. Natural language. Handling natural languages requires recognizing sequences of words, which is a perfect application for string based transitions. Text search. String based transition are key for efficient text search algorithms, allowing for rapid keyword identification. Defining string based transition function. Extension. The transition function is extended to accept strings as input rather than single characters. Mapping. It maps a state and a string to a next state, enabling the processing of entire sequences. Deterministic. String based transition function remain deterministic, ensuring a unique next state for a given input. Properties of string based transition functions. First one, closure. The transition can be defined for any string including empty strings, leading to a complete set of transitions. Composition. Transitions can be combined, allowing for the recognition of complex patterns by composing a simpler string based transition. Concatenation. Transitions for different strings can be concatenated to create transitions for longer strings. Advantages of string based transition: reduce complexity. String based transition simplify finite state machines designed by eliminating the need for separate states for each character combinations. Increased increased expressiveness. They allow finite state machines to recognize more complex patterns and handle larger input sequences. Efficiency. String based transition can be more efficient for processing string, especially for large data sets. Applications. They are crucial for text processing, speech recognition, and other natural language processing tasks. Implementation considerations. Data structures. Trie data structures are commonly used to represent string-based transition functions efficiently. Algorithms like the Okorosik algorithm efficiently implement string-based transition for pattern matching. Complexity. The complexity of string-based transition function depends on the length of the strings and the number of states. Applications and use cases. First one, test processing. String based transition are vital for tasks like text search, word segmentation, and spell checking. Second one, speech recognition. They play a crucial role in recognizing a spoken language, enabling a search to text conversion. Third one, natural language processing. They are used in parsing natural language, understanding syntax, and identifying semantic relationships. The fourth one, data analysis. They can be applied to analyze the text data for patterns, trends, and insights, enabling better decision making. Thank you.